Dear students, welcome to problem solving session number 2 in the chapter of thermodynamics, and we are in our level 1 of the problem solving session. So after the problem solving session number 1, where we did quite a few number of problems in this chapter regarding the problems with enthalpy, we shall now move forward and discuss a few more of them. So this is the first problem of our session, and it says that calculate the heat of hydration of anhydrous copper sulfate into hydrated copper sulfate, and given that the heats of solutions of anhydrous copper sulfate and the hydrated copper sulfate are minus 66.5 and plus 11.7 kilojoule per mole. So what you have, or what are the data that is provided? Now if we move along with the problem, we can find that the data provided are first point, copper sulfate solid plus aqueous solution. It gives us copper sulfate aqueous, where delta H is equal to minus 66.5 kilojoule, and the equation number 2 that is provided, we can say that copper sulfate 5H2O solid plus aqueous solution that gives rise to a total of copper sulfate aqueous with a delta H plus 11.7 kilojoule. So these are the two data that are supplied. Now what is our aim? Our aim is to find out the heat of the following reaction. So our aim is to find out the heat of the following reaction. So what is the reaction? We have copper sulfate solid plus we have 5 moles of water or 5H2O liquid plus aqua or aqueous solution or water. That's giving me copper sulfate dot 5H2O, which is a solid. Hence we can say in this the 5 molecules of water of crystallization are forming the crystals of blue colored copper sulfate. So we have to find out the heat of the following particular equation. Now the equation number 1 that is written above, now this can be written as follows: copper sulfate, or we can say that equation 1 can be written as copper sulfate solid plus 5H2O liquid, giving us copper sulfate 5H2O solid. So here the delta H value is equal to Q1 kilojoule, suppose. The next, so this is pointed out to be equation number 3, and the equation number 4 is copper sulfate 5H2O solid plus aqua is giving rise to copper sulfate aqueous. Here the delta H value is equal to Q2 kilojoule. Now according to Hess's law, I can say that, or by Hess's law, this Q1 plus Q2 is equal to minus 66.5 kilojoule. So Q1 plus Q2 gives rise to minus 66.5 kilojoule. Now further we can say that the equations 2 and equation 4, so this is equation number 4, and I can say that the equation 2 and equation 4 are both the same. Therefore I can say that Q2 is equal to 11.7 kilojoule. Therefore we can say that Q1 is equal to minus 66.5 minus 11.7 kilojoule, which is equal to minus 78.2 kilojoule. So the equation 3 can be written as copper sulfate solid plus 5H2O liquid gives us copper sulfate dot 5H2O, which is also a solid. Here the delta H value is equal to minus 78.2 kilojoule. So this is what we had aimed, or this is what we were searching for. Hence we can say that the required value for the heat of hydration is equal to minus 78.2 kilojoule. So this was the first problem of our today's session.